Thank you very much. Thank you for coming along and hanging out, and it's good to see you all here at DevFest. I'm intrigued as to how being GD is more important, because I'm pretty sure Twilio still pays me, but thank you for that. So yeah, as we've said, my name's Nash. I'm a developer evangelist at Twilio. Can I ask who here has heard of Twilio at all before? Quite a few people, all right. But for those who haven't, Twilio is an API platform for communications. That means it's a whole bunch of APIs that you can use inside of your apps to do anything from sending and receiving a text message, making and receiving a phone call, sending emails, faxes, all sorts of stuff, video chats, everything. If you want to hear anything about that, I'm around for the rest of the day. Come and talk to me, and I can answer any questions. If you've got something cool with it, on the other hand, I'd also love to hear about it as well. So if you've done something cool with Twilio, let me know. But I'm here to talk about that. I'm here to talk about Project Fugu. And as we said in the introduction, native apps have been, I'm not going to say dominant. In fact, I'm going to step back from that. I mean, it's perfectly reasonable for Luke to say so, as he is an Android application developer. But there was a study done a couple of years ago which said that the average number of applications anybody installed in a month was 0. I bet you have applications that you use every day, but I bet the application you use the most is the browser. And installing applications is not that much fun either. So Project Fugu the web has been working for a long time to try and catch up with things that native applications allow you to do, and hopefully do them better. And that's what we've got with Project Fugu right now. And in the past, we've added things like device access for things like cameras, and that has allowed us to do kind of video chats and things on the web. We've added sensor APIs and things, so you can do fancy stuff with orientation of the device and all things like that. All stuff that a native application would be able to do. Project Fugu is this latest push to bring that to the web. Fugu is the Chrome developer team's attempt at this. They are building and testing these processes, these new features, outside of, not as part of the standards process necessarily, but with an aim to push them towards the standards process as other browsers decide that this is a good idea or not. Why is it called Project Fugu? I guess is a pretty good question. This is the Fugu, or the pufferfish, or blowfish, or whatever you want to call it. If you're not aware, Fugu is a delicacy in Japan. However, it's also deadly. Many different parts of this will kill you. Yet the Japanese are still super into eating it. There's hundreds of restaurants that allow you to order it. But in order to correctly prepare a Fugu fish, you must go through years and years of training so that you don't kill your customers. In fact, I was just looking it up before the last talk started, and in the last last couple of decades, most of the deaths due to eating poisoned or poisonous fugu fish, toxic fugu fish, were because they were prepared at home. So this is definitely a don't try this at home. What does that mean for the web, though? Well, we have to. The web has this ability to be in everybody's pocket without having to install something. You already have a browser, you're already on the internet, you're already on the web. We have to be careful as we prepare newer frameworks and newer APIs, such that one, they are decent APIs, that they're developers, ones that developers will want to use, and ones that as developers we can achieve what we want to in our applications with them. But secondly, privacy and security of our users' data as well. And we'll see this in a few of the APIs that I'm going to talk through as part of this talk, because we don't want users to be put at risk by malicious applications who want to steal their data, and we don't want to accidentally put them at risk by stealing it ourselves. Hopefully we'll see that going through. So the idea of Fugu is that these are dangerous APIs that could be used to abuse users, and we don't want that to happen. So, how does this work? Well, in the past, when we've tested out new APIs, you've probably seen vendor prefixes. I don't know if you remember a request animation frame, for example, where if you wanted to use request animation frame, you obviously looked out for Windows request animation frame, but also like maybe there's others one, and also the WebKit one, and I guess probably Opera just in case, and then MS for Internet Explorer, and you would write code like this. And we'd get disappointed about it, or we wouldn't, right? there was a case where eventually Firefox started implementing WebKit prefixed CSS properties because nobody had ever bothered to update their CSS to use the actual standards-based stuff. So in order to get decent things into Firefox, they needed to actually implement the prefix. This was bad. We all agreed that was a bad idea. And so now, you may have, if you've experimented with this at all, we use feature flags to hide new APIs away. If you're in Chrome, you go to Chrome:/flags and find the enable experimental web platform features flag, turn that one on, and things get exciting. Indeed, there's actually a warning there, warning experimental features ahead. It's a good way to crash your browser once in a while without you even doing anything. I have a couple turned on here actually. There's the experimental web platform features, but also down here the developing tools experiments, which is a fun way to crash your dev tools every now and again as well. Turn those on, we get the access to these new APIs. Or indeed, I used the yellow Chrome logo earlier in the slides. Use Canary, that has this turned on all the time and crashes all the time. I'm telling you this because this presentation is also running in Canary, so if it crashes, it's not my fault. Cool. So we've got these flags, and there are flags inside other browsers as well, but you won't find these features there yet because this is Chrome, as I said. So cool, we have flags, but we want to test these things with real users, and you can't kind of contact your users and say, hey, can you put your browser in the crashy, dangerous state, please? So in order to test these things with real-life users, which we absolutely have to, we also have the Chrome team started using a thing called origin trials. I really like this. It sounds like a young adult dystopian future. It's much less exciting than that, sadly. You know, let's think about it like the origin trials coming this summer. Origin trials are a way that we can enable these experimental flag features for our users without having to wait for it to be pushed into production by the browser itself. You can go here to find a list of the current origin trials. In fact, let's go see if they're there. It's a good test. These are the current origin trials available in Chrome. Exciting to see that my internet is running real fast here. There's more than just loading. There we go. There's actually loads of them. And we'll see some of these in a minute. But if you want to use them, you just kind of register for an origin trial, and that gives you access to it. That's twice. Cool. That's fine. Oh no. It's exciting that I left my slides back here somewhere. There they are. Cool. Slightly optional. I don't know what's happening. Okay, we'll carry on. It's not a problem. Those are all available. You register for an origin trial, and once you've done so, they're not discriminatory. Anybody can register for an origin trial, and you get access to a key that allows you to use it. Then if you add a meta tag like this onto your page with the feature, in this case this actually was an origin trial. I took part in on my own website. That's mean anybody can do it. All three of my users loved it. For the web share API. It expired a few years ago, as you can see as well. And you have the content there. That's the key that just says to the browser, hey, this site is able to do this. Notably, we do have an expiry date there. Origin trials have to expire, and they have this fixed time limit. This means that you should always build with them defensively. Don't ever expect them to be there, because they will be taken away again. The origin trial exists so that eventually it can be part of a standards process, and in the middle of that bit, they'll take it away again. I think this is an interesting fact that they actually cancelled if the global usage of this origin trial exceeds 0.5% of page views in Chrome. This means that this is so that it's not kind of overly used, right? This is a test that's supposed to be a feature flag for certain users to use. If we get to 0.5%, which is actually the Chrome's deprecation level as well, after a feature dies out to less than 0.5%, that's when they're like, okay, we can actually turn this off now. If an origin trial goes above that usage, it also gets turned off. And ultimately, the trial and the feature may not ship. We may never have some of these APIs that I'm going to talk about today in the browser, Or they may be different APIs that do the same thing, because these trials and things allowed us to figure out that we weren't doing this right. So cool, let's get on with the Fugu. Desperately concerned about my slides at this point because of this being off to the right-hand side thing, but okay, I'm still going to do that. Fine. We're going to talk about 4 new APIs today. There are more. As we saw that list of origin trials, there are loads of things coming up. We're going to talk about 4 for this. The wake lock, super exciting. Contact picker, native file system, and finally shape detection APIs. And these are all exciting for actually very different reasons, which we're going to show you. So first up, the wake lock. This is one of those things that I think has been weird about browsers. Native applications have control over the screen and actually have power options, which is kind of funny. And we have the full screen API in the browser and things like that to allow us to do things like take over the screen, but we still don't get control over whether that screen exists or not. And this is fine. Like actually, when you're playing a video into a full screen thing, the browser will stay awake and will keep the underlying operating system awake. You do not want your show to stop playing because you just didn't touch your browser for a while. That will be a terrible experience. But there are other applications that we can build that have this kind of problem as well. Anything like an interactive game that maybe doesn't interact by having people touch the screen. I've seen some, as I mentioned earlier, orientation sensors are great to play a game like that, but useless if the screen then turns off after a minute. Same thing, a couple of years ago, The Guardian did an example, I think it was called Rio Run, which was an interactive experience looking through the Olympics in Rio. And again, you didn't touch the screen, but the thing carried on. And but if the screen goes to sleep, the screen goes to sleep, you're losing it. Now, I thought I'd been talking long enough at this point for my screen to actually go to sleep, but it's apparently decided that it's taking its own wake lock on and not going to play nice with my demo. So, fine. I'm going to show you anyway, because within the browser here, we now have access to a wake lock, which we can take control of. Actually, I can show you that. Screen or system are parts of the wake lock that are available to us. Screen keeps the screen awake. System, the intention is to not necessarily keep the screen awake, but keep the system running so that we can do things in the background. This would be useful for things like an exercise application where you don't need the screen on, but it wants to keep tracking your geolocation, for example. But don't try this with system yet. No one's implemented it. Only screen exists so far. And so the demo was going to be me talking and talking and talking, but we've seen that. Let's just see the code. I'm just going to put this screen into a wake lock so it never goes to sleep, even though it was never apparently going to sleep. So the wake lock exists on the navigator element. So I'm gonna, it's also promise-based. Navigator.wakelock, and you just request the screen. And cool, I get that. I now actually have a wake lock on the screen. The promise resolved and assigned back via the await there, and we have what's called the wake lock sentinel. This was exciting news to me this morning as I was going back over this talk, and I'd never heard of the wake lock sentinel before. I'll show you why in a minute. But the wake lock sentinel that allows us to, well, we can set a listener to it to see when it is released, when the lock is released, but we can also use it to release the lock as well. And so now the screen can go to sleep again. Let's put it back on. Releasing lock. So as I said, I found out this earlier today as my demo didn't work, and I was disappointed about that. Because we used to release the lock like this. Effectively, the navigator, the wake lock request was a promise that never resolved. The idea was if you started the request, if it didn't fail for some reason, you had a wake lock. And then you used the abort controller, which you pass the signal through to the wake lock like this. And then later you could abort that, which would release the wake lock. This was confusing. Having a promise that never resolved is an odd behavior. And there are other issues with it instead. And when I was learning about this, I actually learned that the abort controller came around for cancelable promises in general. This is the way we eventually implemented promises that we could cancel in any way. So if you're using the fetch API, for example, and you want to fetch a URL, you can pass it the signal to an abort controller and then later cancel it using that. So I was excited to find out that that exists now, which is cool. Adds a lot more code to our fetch API requests, but if you need to be able to cancel one of them, this is how you do it. And then the important thing is you catch and the error is an abort error. You're like, okay, that was me. I meant to do that. Cool. Carry on. Instead of the wait lock, now we get that wait lock sentinel object. I don't know why it's called a sentinel. There's nothing else in the web, as far as I can remember, called a sentinel, aside from the matrix. That's where we're going now. Cool. So instead, yes, we request the wait lock, which resolves with our sentinel. We can listen to it being released, and then later, in this particular case, down at the bottom of the screen, set a timeout to release that wait lock in 5 seconds. Totally useless bit of code, obviously. Nobody's screen is going to sleep under 5 seconds, but that is what it would look like. You do also, with the wait lock, have to pay attention to changing what screen you're looking at. Your application is actually only able to hold this lock whilst your page is actually visible and being used. So if the person goes to another tab, you no longer have control over this, and the wait lock will be released again. We can actually probably see that if do I have a wait lock right now? I do, cool. So if I was actually to change tab to somewhere else, over there, it should have actually, if we go back, I wasn't listening to it, so we've not add listener release, console.log release. Yes, correct. I added a number of brackets there. Not enough brackets there. No, okay, we'll give up on that. It would have shown, yeah, we could go away, come back, find it had been released, and so then you have to listen to the page, come back to life, and re-access the wait lock. The wait lock itself doesn't require you to ask for permission, which is kind of interesting. Again, I think a reason why it's behind all these origin trials. Should we be asking permission to take control of the screen and or the system when that gets implemented? Maybe. We're a web browser. We need to think about these things. I will be following up with these slides online later, so these links are all available for you to check out. Again, I learned things about the wait lock this morning, and while this article says it's the 2018 December edition, it's been updated without a changelog, which made it hard to find out what had changed. Again, these are all behind flags, so this doesn't break anything right now, unless you wrote a demo. Cool. The Contact Picker API. This one I find fascinating, and very much is one of those ones where we have native applications to complain about because they have this access, these APIs available to them. So the Contact API is important for this origin trial because it's private data. Very private data. It's your contacts. It's their way of being contacted. Do you remember back a few years ago when Twitter was found out if you installed their app on an Android device, just take your contacts and throw them all up to the cloud? You know, like Twitter knew all of your friends' phone numbers and you didn't know why. And it's because there were not these restrictions on Android applications at the time. Or they would throw up that big list of restrictions at the start and say, hey, we would like access to everything. And you're like, I just wanted Twitter, okay, cool. That's bad, right? And Android moved off of that model, and all of the web, Android and iOS all have kind of permissions as you need them these days. If you try to use something that is not, you don't yet have permission for, it pops a permissions dialog. Now there are other problems with that, but we'll get to those later. The Contact Picker API, therefore, has to consider these things. And so first, with it, the code looks like this. We check whether it's supported. Contacts is also on the navigator, like the wait lock. And we do want to check the instance of a contacts manager. And once we have that access, we can do things like get contact. We we set up some properties that we want out of this. We get name, telephones, number, email addresses, and regular addresses. We can ask for them. We won't necessarily have them, which is interesting. You can also throw in some options. In this case, multiple false means I only want one. That's what I'm going to use in my example. But you can ask for multiple contacts if that is useful to you, if you actually are building something where a user wants to upload their contacts to you. And then we just ask the navigator to select using the properties we're asked for and the options we set. And that returns an array, even if you only ask for one, and gives you a contact. That contact will then look a bit like this. It's just an object with the properties that you asked for. If that property didn't have anything, like in this case email, you would not have anything in the array there. And then also the name, you get the telephone number. Address looks like another thing. So addresses, if you ask for them, they actually come back as proper address objects from the web. Weirdly enough, they're inherited from the addresses that the payment API set up. Because in order to pay for stuff, you need credit cards have addresses, and these are existing objects. So the contact picker API currently has lent on that existing address object. Let's see this one in action. And for this, I'm actually going to my phone, my Android device over here, in which I built a small phone application. It does two things. It allows you to choose a contact, and this is the contact picker API in play. So this button on the screen here, hello, yeah. I once tried to pay for this application. It says it's ad supported otherwise, and it literally wouldn't allow me to. So apologies for anything that comes on screen. In the meantime, I can use the phone and show you this. I click that button, choose contact, and it brings up my list of contacts, which is pretty exciting, right? And here we can select only one, because we only picked, I've only picked one in this particular case. I'm not going to show you people's, all my contacts there, so I'm just going to search through and add myself. 2 people are now selected. How do I manage that? It's fascinating. Oh no, I know what's happened. Give me one second. I know what you're thinking. You're thinking, Aardvark Johnson, who's he? And how do you know Aardvark Johnson second? I just wish I had friends called that. I've selected my own contact, and so the button down here, because I got a contact, has changed to dial Phil Nash, which is working. And so if I now hit that, it's using that phone number that it got, which is actually ringing here on this phone. You're not going to do it, are you? Oh my god. Ah, cool. Yeah, now it's talking. I'll hang up to myself. Hey. No, I said hang up and select another contact. Get out of here. Thank you. I said hang up. I think it might have called me twice because I had 2 phone numbers. Yeah, there we go. Get out. And now it's probably hung up and it's ready to dial again. Oh yeah, I gave myself a list of phone numbers there. To fix that in the demo, obviously. So the contact picker API allows us that access to email addresses, telephone numbers, real addresses, and names of the contacts of your user that allows you to have them, which is great. There are some links to this. That is not my contact picker demo, that's another one. I am still in the midst of sorting out the spaghetti code that is my demos right now, but they will go online eventually. Cool. I'm running lowish on time now, so let's get carried on with it. The native file system API. Woo! The native file system API used to look like this for us, the input type file, right, which you can't style, because that's not a button, that's an input element, and you can't change the text that says no file chosen. You can't change the text. And that would give you access to files, right? And that was sort of fine, and we could hack around that. And then the whole drag and drop API arrived, and so we could kind of get file objects if you drag them and drop them onto the page. But dragging and dropping onto a page on a mobile device, ooh, not quite the same. So the native file system API exists for us to be able to not only get access to files in an easier way than this, and an easier way than dragging and dropping onto the screen, but via an actual API. But it also allows us to save back to the API, save back to the file system, access to write back to the disk or the device, whatever you want. This used to be the way you'd save it, right? So the download attribute on the anchor tag, cool, and pass it a blob and maybe it'll save it, but you don't get to choose what it's saved as, or terrible. So the native file system API works around file handles. Again, this comes with a sort of permissions thing. Well, in this case, the permission is very much we open the file dialog, the native one that you expect. So it's a promise, so once it returns, you have a handler to a file, or indeed a directory, you can do it that way as well. And once you have the file handle, you call getFile on it, which will give you the file, and then in this particular case, if I know that the file is going to be a text file, I can call text on it, which is again a promise. You might have seen this in things like the fetch API, where you call text or JSON or blob on the resulting response from a fetch. In this case, you can do the same but on a file object and asynchronously retrieve either the text or binary contents of a file. And once you've done that, you can save files. So this is the same function, choose file system entries, which you see at the bottom here, but instead we give it a bunch of options. And if you give it the option save file, then you can save to that place, which is kind of cool, and you can add some other bits, extensions, mount types, and such. But more exciting to see this is in demo format. Not you. Here we go. So I have, I'm in a browser here, and this is accessing the local file system. So that is simply a button that says load file at the top there, and it allows me to load a file. I'm going to go meta on this because I'm actually loading the file that we're looking at in the browser as well. I'm using, and I think this is quite exciting actually. This is Monaco, which is the editor that lives inside VS Code. It's available as a standalone package, and so we can start to add stuff to it. And you see, we're actually getting inside the browser with literally almost no code whatsoever. Completion, syntax highlighting, and everything. So if I write hello devfist in there and then save it, we have to get permission to save, which is good. And so if I accept saving that, that's now been saved. We actually now can keep saving things, so I can actually do this again. Save it, and it's not going to answer me again, because whilst this page is alive, I can keep saving. And you might not be able to. Yeah, up in the top corner there, that little file icon with an arrow at the bottom is a little icon that's saying, hey, you've given access to save files in this. And we can edit index.html in this case. We can remove that access right here, but I don't want to. So if I refresh the page, I've now got these two, hello devfest again, as part of the thing. So we can build an entire text editor in the browser. Somewhat impressively, I think last week Microsoft, or even earlier this week, kind of created VS Code Online, I think was it, where you have a whole Linux machine in the background to run your things. And I don't know, we can do it online in the browser without the Linux machine in the background. We can use our own machine again. That's how I like to do that, but hey, we'll see. That's pretty cool, I think. Again, the important thing is that we are looking at those request and save permissions to make sure that these work for our users. We're talking about permissions there. I've talked about them already. There are some links to this with a file system demo. This is the Chrome Labs demo for it. They also made a text editor, and it's got a nice menu bar, but it doesn't have Monaco involved, so mine is cool. Final one, shape detection API. The shape detection API is exciting because this brings the remit of computer vision into the land of the browser. I'll get to that in a minute. I remember playing years ago in a hack day with a JavaScript compiled version of OpenCV to do facial detection in the browser, and it was slow and it was horrible. But I built a musical face-based theremin with it. So I had fun, but never made anything actually practical. Now, of course, these days we can take our kind of machine learning things like OpenCV and perhaps you have a TensorFlow thing which does it via the GPU, or you can compile it to WebAssembly to make it quicker. But if it was just a JavaScript API that the browser implemented and can make it better, let's go with that instead. The shape detection API in Chrome right now does three things: face detection, text recognition, and barcode detection. You can build the QR code reader of your dreams inside the browser right now using this. But for the demo, I wanted to talk about faces, because I will rewrite my face theremin using just this, and it will take over the internet. It's almost entirely this line of code. We use the face detector, which is available on the window, called detect on it, and give it either a canvas object or image data, however you get hold of it, and it will detect. And then once you've got them detected, we get a bunch of information. So here is my facial detection one. I'm going to start the camera using WebRTC or Get User Media, and right now it's pumping the source the video stream into a video element, taking the frames from the video element, moving them into a canvas, which is this canvas, and then it's calling face detection on a request animation frame loop as well. And so when I put my face involved in it, I can then draw where my face is on the screen, which is kind of like it. And then you can see kind of the objects that we're getting out of this actually comes with a bunch of things. You can do, it actually has feature detection, so it will tell you where eyes, nose, and mouth is. And the fun part of this is actually you need all of those to have a face, so if I didn't have a mouth, I wouldn't have a face. It's good to know. And then you get this bounding box, which is the thing that I'm drawing there as well. That is where we think my face is right now, according to the browser. It works in exciting real time, and I'm not going to show it on the browser because we're on the device because it's run out of time. But it does run on this Motorola G4 mid-range Android device as well, which I think is incredible. Other bits about the other ones, the barcode detection detects any number of barcodes, which is very cool, not just QR, but all sorts of products. The text detection on some devices can also do OCR, character recognition. Ultimately, you'd be able to build something like the Google Translate that uses the camera and in place rewrites the text on screen entirely inside a browser, which I think is cool. Those are some links. As I said, I'll put these slides up later because that is all I've got for you today. The web has a lot to offer, and we're getting a lot more for it, which I'm excited to obviously talk about, but play with as well. We need to get it right, and so that's why you need to play with it too. So if you found anything interesting here, or even if you just want to browse through that list of other origin trials or other APIs coming up, go out there and experiment, see what you can do with the web today, or see what you can do with the web tomorrow. That's all I've got. My name is Nash, I'm a developer of Android Tutorial. I'm around for the rest of the day for any questions you have. Otherwise, thank you very much.